Okay, folks, this is chapter 3-1. This is recording number 4. Okay, the third one that we're going to talk about of the measures of central tendency, the third one is called the mode. This is the kind of the easiest one, so to speak. Now, the idea here is it's just the value that occurs most often in a data set. Okay, so it's the guy that occurs the most often. Okay, so now if you have a data set that has only one value that occurs with the greatest frequency, in other words, the greatest number of times, we say that it's unimodal. Okay, uni means one, like unicycle, it only has one wheel. If there's two values that occur with the same greatest frequency, well, they're both considered to be the mode, and we say that the data set is bimodal, like a bicycle has two gates, two wheels. Okay, and finally, if you have more than if you have three or more, then we say that it's multimodal. Okay, but it also could have no mode. All right. Now it's very important though. Don't say that the mode is zero. It just doesn't have a mode. Okay. So here's an example here. Public libraries. The number of public libraries. Okay. It helps you see things if you line them up in order. And you say, okay, 77 occurs twice, therefore it is the mode. It's the most common one. I guess I'm trying to think of a good example in everyday life. Let's say you're a school teacher and you're teaching sixth graders, and you say, well, I've got 40 kids in my classroom, 38 of them are 11 years old. One of them is really, really smart, got advanced. He's only 6 years old, okay? And another one got held back a couple of times. He's 13 years old. Okay, so, if someone said, well, what's your average age? You'd want to say, well, the average age is 11 years old, even though I've got a 6-year-old and I've got a 13-year-old. That's probably what you would say. So that would be using mode appropriately. You'd say, well, the average is 11 because out of the 40 kids, 38 of them are 11 years old. So maybe that's a good example, maybe it's not. Okay, so you look at this and you can, here's another example. I'll let you look at that. 104 and 109, both of them occur 5 times. So we say that the modes are 104 and 109. Okay, so very, very straightforward, I think. Okay, same idea here with classes. The modal class is the one that occurs, that has uh, the largest frequency. So using this data that we had before, this class, there's 13 in this particular class. So we say that's the modal class. Okay, so these are all just definitions. Not a whole lot of math here. There's not a lot of computations. It's just some definitions that we have to deal with. Now, here's something else that kind of, uh, might be interesting. What if you have a situation where it doesn't really lend itself to the mean or the median? Okay, um, like if you have different categories. So we're talking about if the data is categorical, there's different categories like soft drinks, water, milk. See, that's different from what we had before. Before we had a class where it was one category. The category was the salary, right? Okay. Up here, talking about nuclear reactors. There's no different categories. Well, now we've got different categories here. We've got soft drinks, we've got water, we've got milk, and so forth. So it really isn't appropriate to try to come up with a mean or a median here. How would you do it, right? It doesn't make any sense. So you could talk about the mode, however. You could talk about the mode because you would say, well, the soft drinks is the most common, has the largest frequency. So we can say that the mode or the most typical drink is a soft drink. All right, that's not particularly interesting, but this next thing I think is very interesting because it comes up in real life in the scientific world all the time. Whenever you're doing experiments of any sort whatsoever, any kind of a testing program or what that you're doing, you always have to be aware of the possibility of test errors. So that's an extremely high or extremely low data point or data value. It can have a very striking effect, a very large effect on the mean of the data set. That's my example of Bill Gates walks into the room. Mark Zuckerberg walks into the room. It has a huge effect, so it can make things meaningless, okay? We call those outliers. Okay, when we talk about outliers, we're talking about data values that are so different from everybody else. We think, geez, do we really want to include that? I mean, do you really want to include Bill Gates or Mark Zuckerberg when we're trying to figure out what the average uh, wealth is of a student? That doesn't make any sense, right? So you sometimes will say, well, I'm going to toss out these outliers. That's why you call them outliers. They're outside the realm of the normal. So we toss them out, okay? Here's a good example of that you can actually calculate. You know, you've got see, this almost looks like a category, but it's not. These are the category is staff. Okay, obviously there's different members of the staff, but this is not a categorical data. This is these are data points. This guy has a salary of 100,000. This guy has a salary of 40,000. So this is X sub 1, X sub 2, X sub 3, X sub 4, X sub 5. So this is not categorical data. In any event, if you did the calculations on this, okay, if you calculated the mean, the median, and the mode, what answers would you come up with? Well, finding the mean is just very, very straightforward. You just add them all up, divide by the number of data points, you come up with an answer. Now, by the way, you'll notice here he says mu. So the fact that he says mu is telling me that this is a parameter, not a statistic. It's a parameter because this is the entire population that we're interested in. This is a small company. This is not a sample. It's not a sample. So that's why we're not saying X bar here. We're saying mu because this is the entire population. When we calculate the mu, we come up with 40,000. So that's what the mean is. Well, if you line these guys up, they're already lined up. What's the median? Well, 24,000 is the median because if you have 24,000, there's two data points up this way, and there's two data points down this way. So the median is 24,000. The mode is 18,000 because there's two values at 18,000. So as you can see, this is an example of where it makes a big deal difference whether you're using the mean, the median, or the mode. So if someone were to say to you, oh, okay, you know what, this small company, the average salary is $40,000. That is misleading because the word average can mean either the mean or the median or the mode. So that person could be misleading you. Maybe on purpose, maybe not. So if he says, well, the average is 40,000, you have to ask him, well, what is that? Is that the mean? Is that the median or the mode? Okay. All right. So this is obviously what it says here. Okay. All right. So now the mid-range is kind of a rough estimate of the middle. It's something that you might, like before when we had we were trying to figure out what the mean was of grouped data. We came up with a mid-range or the midpoint. Okay, so this is basically the same thing. The mid-range is basically the midpoint. Okay, it's the highest and lowest value of the data set, and you divide it by 2. That gives you the guy in the middle. Okay, so rough estimate of the average, but obviously it can be very much affected by an extremely high value or extremely low value. So Bill Gates' example uh, illustrates this concept. So we got the bank failures here. I'm going to let you work your way through these. They're very, very straightforward. Okay. All right. So now here's an important point. You can have several different measures that can be used for an average. The ones that we've talked about are the most common ones: mean, median, mode, and mid-range. They have their own specific purpose. But if you look at the exercises, I'm going to try to do those exercises and put them on a video. if you look at the exercises, there's other averages, and these other averages have their own good news and bad news, their own applications that where you would use those. So I'll try to get to those as soon as I can. Okay, and they're limited. They're limited to specific areas. You use them in a certain context. Okay, so now we'll talk about what's called the weighted mean. So whenever you hear an instructor, as an example, an instructor like myself, in my syllabus, I'll say things like, okay, the homework counts as 10%, the exams count for 30%, all of the exams all together count as 30%, and the final exam counts as 30%. Did I say that right? So it's 30% for the final, 30% for all the exams, and well, obviously I'm not adding up to enough. Okay, so here's for my syllabus. The homework and the quizzes counts as 10%, the exams count for 60%, and then the final exam counts for 30%. Okay, so that's a typical weighted average. You weight each of those things a certain amount, and that gives you the weighted average, and that's the average that you're dealing with. So here's another example: average cost of gasoline for the 3 different taxis. Okay, you got the 3 different prices that they pay. You could just add them up, and come up with an average, right? But not all the drivers purchase the same number of gallons, okay? So if you're a businessman, you really want to know what is the average price, the true average cost per gallon. I really should keep into consideration, or take into consideration, the number of gallons that each driver purchased. Okay, now that's called a weighted mean. So the weighted mean, here again, the little subscript, the 1 and the 1, the 2 and the 2, what that's referring to is not a number in the sense that we're going to use it as a number. We're not going to multiply or add or do anything to that 1 there. That is just identifying which of the taxi cabs we're dealing with. So in this particular situation here, we had 3 taxis, so it'd be W sub 1 times X sub 1 plus W sub 2 times X sub 2 plus W sub 3 times X sub 3. There's only 3 guys on the top. So you could have just as easily, let's suppose the names of the taxi cab drivers was Adam, Bill, and Charlie. You could have just as easily said weight of Adam and then the value for Adam. Weight of Bill times the value of Bill. You could have had their names as a subscript, but this is typically done this way because it's just more convenient to have a number for a subscript. Okay, so on the top you multiply by the weight, and on the bottom you add up all of the weights. So let's take a look as an example here. Okay, weighted mean for a grade point average. The courses vary in their credit value, so we have to have the number of credits will be used as a weight. Okay, so here's this kid that has a grade. This one has credits of 3, credits of 3, credits of 4, credits of 2. So you crank out the numbers, you multiply by the weights, and on the bottom you have the total number for the weights, the total number of credits on the bottom. Okay, and that gives you what you divide by, so that the grade point average is 2.7. Okay. All right, so one of the things I like about, so I hope that's clear. One of the things I like about this book, I think is a great book, is he summarizes things for you. Here's the summary of everything. If nothing else, if you don't take any other notes from the book, make a photocopy of these pages. Here's a summary, kind of tells you everything that you need to know about it. Okay. Here's the properties and uses of central tendency. Why do we do this? What's the mean good for? Why do we use the mean sometimes? Why do we use the median sometimes? Okay, I'm going to let you read that. I think it's pretty clear, and we've talked about it as we went along here, okay? All right. Okay, and I think we may have mentioned this before, talking about distribution shapes. Some of we talk about that being skewed or not skewed. They can be symmetric or negatively skewed. I can't really add anything to what the author says, so I'm not going to try to explain this. I think it's pretty clearly written. Okay, as always, if you have any questions, send me an email. I'll be happy to clarify it for you. Okay, all right. So these are pretty straightforward, I think. So that wraps up this section, section 3-1. Okay, So that's the end of this video.